Today is actually kind of an easy period. I'm going to remind you about integrals as area and Leibniz notation, and then we're going to learn a bunch of rules about definite integrals. Many of them are going to make a lot of sense to you. A couple of them might be a little bit difficult. Then we're going to do a couple of examples utilizing those rules of definite integrals, and then we're done. I mean, then you get to do a lot of problems that aren't going to be that difficult. Well, let's get started. I just want to remind you that what a definite integral is. If like I were to do the integral from -2 to +2 of x to the third dx, what I'm doing is essentially graphing the function y equals x to the third. So, you know, the function y equals x to the third looks like that. And then I'm getting the area from -2 to +2. I'm getting this area and this area. Before I go any further, if you were to do this on your graphing calculator, what answer do you suppose your graphing calculator would give you?
0.
If you're thinking 0, you're right, because areas below the x-axis are negative, because those are like rectangles with negative heights, and areas above the x-axis, I'm so sorry about my cough. My toes. The areas above the x-axis are positive, and so they would cancel in this case. And this is the starting point, and that's the ending point, and that's it. So you guys got that? All right, then let's learn a bunch of rules of definite integrals. And I have them on the screen, so. These are all in your textbook, so you don't have to feverishly write this down at all. I'd say just look at your textbook. Oh, how interesting. My computer got shut down, so it's not on there anymore. Sounds like it. Ha, 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 ha.
Well, it looks like you just take the day off.
What's that?
Looks like you have to take the day off.
You know what? I should take a mental health day.
You should. Spend it with your kids.
That's right. You know, my problem is, like, it hurts my mental health when I take days off, because then I just get behind. So actually, I don't do mental health days. I do the opposite of mental health. Okay. Okay, here come the rules, and I want to say again, don't spend your time. Hey, look who's here! It's Erica Mutaka. I'm going to erase you. You are now present. Oh, document recovery, yeah, because. Alrighty. So, I just want to let you know that these rules are actually in your textbook on page 269. So don't be feverishly writing this stuff down. It's right here on page 269 of your textbook. Look at number 1, order of integration. Someone tell me, why is that true? Why would the integral from b to a be the opposite of the integral from a to b? Yes?
You switched the order to doing it?
Yeah, okay, that's good enough. You switch the order that you're doing it in, right? If I have the integral from -2 to 2 of x to the third dx, where I'm looking at this, okay, going from -2 to 2, right? I'm going from left to right. But if I integrate from 2 to -2 of x to the third dx, I'm going from right to left. And we all know from reading manga, when you go right to left, it's different. You guys okay with that?
Yeah.
There's another reason. Remember how the integral, all it is really the sum of a bunch of heights times a bunch of widths? Remember that? The f of c sub k delta x thing? And delta x was equal to b minus a over n, where n is the number of partitions. Well, you know, if I switch my b and my a, my delta x becomes negative. And that's all that happened. I'm switching the b and the a, so the delta x becomes negative. So all my widths are negative instead of positive, so it gets me the negative of the integral. Look at the second rule. The integral from a to a of f of x equals 0, no matter what f of x is. Why would that be true? What's that, Justin?
You're not moving anywhere on the graph.
Sure, you're not moving anywhere on the graph. Let's say here's a. What's the integral from a to a going to get me? Yeah, 0. I'm getting the area under a point on the graph. I'm getting the area of this line. Well, a line has no area. A one-dimensional object doesn't have a two-dimensional area. So I hope it makes sense that when you integrate from a to a, no matter what the function is, you get 0. Look at this guy. What are they saying there? What is number 3 saying? What is number 3 telling you you're able to do?
You're able to move to
Yes, Abigail.
No.
No, you go ahead, Abigail. He talks all the time.
Oh, okay, so basically that you can multiply by the coefficient of the x, and then you can multiply it to the area and even everything. So like, it's in the next one. So you can do, like, if your function is a constant, you can do, I think it's b minus a times your coefficient k, and then you do the same.
Okay, good for you. Yeah. And the way you're going to be using this most frequently is just you're going to be taking that k out.
Yeah.
That's it. It's like, that's it. You're just taking the k out. It's kind of like when you had factoring, where if I had 3x squared plus 3x and you factor out the 3, you know what I mean? That's all that's happening here. If you got a 3 here, you just take it outside the integral. Yeah. And I hope you see that that's going to be true, just because, if I had, imagine something as simple as like I think Abigail was alluding to, if I had some constant graph like y equals 2, and I wanted the area from 0 to 3 of y equals 2, that would be 6, right? But what if I wanted to multiply this by 5? Well, that just means that I'm up at 10, and I've just multiplied my area by 5. I mean, essentially all that k is doing is multiplying each and every height, the height of each and every rectangle by k. And multiplying the height of height of each and every rectangle by k is like multiplying the entire area by k. But if none of that makes sense, that's okay. Just remember this. Boop. Here, let's do sum and difference. The sum of the integrals is the integral of the sum. The difference of the integral of the difference is the difference of the integrals. That's another thing about graphs, If I had 2 graphs and I wanted to add them together, all I'm doing is adding the y coordinates together. And since I'm adding all the y coordinates, then I'm just getting the integral of the sum of the 2 functions, which is going to be the same as the sum of the integrals. And again, I'm not going to really, worry about that. I'm not going to strain to have it make a lot of sense to you. Just I'm looking at my time. I'm not going to strain to make a lot of sense to you. I mean, just believe it. But know that its origins are in the graphs themselves. If I add the y coordinates, it's the same as the sum of the areas. This is the first one that I think is kind of tricky and interesting, the additivity one. The integral from a to b plus the integral from b to c is equal to the integral to a to c. Why is that true? Yes?
Because the intervals from A to B, and then it's followed up by the B to C, so A to C is the same.
Beautiful. Great. Hey, let's take a look at that. If I had some graph like this, and here's A, and here's B, and here's C, right? Doesn't it make sense that the integral from A to B plus the integral from B to C would equal the integral from A to C? You guys hear that? That makes sense? But let me give you an example. What if the A, B, and C aren't in that order? What if I had this, where here's A, here's C, and here's B? Is that still going to be true? Is the integral from a to b plus the integral from b to c going to equal the integral from a to c? Why are you guys are so easily led here? Why would you say that's true? I mean, from a to b is this gigantic area.
But then you're going backwards.
Oh.
So you subtract it.
Oh my God, Andrew, you're right. I'm going backwards. I'm going from B to C, so I have to subtract from B to C, and then that just leaves me A to C. Good for you guys. So it doesn't matter what A, B, and C are. It doesn't matter how they're arranged. A to B plus B to C gets you A to C. You guys believe?
Yes.
Okay, let's look at rule number 6. Please read the min-max inequality rule. I wish I could cover up part of the LCD screen like I used to do with my LCD projector. Okay. So imagine I have this function, okay? Let's say here's 2 and here's 5 and here's 3, oh, I don't know, let's say it's 1. Here's 1 and here's 4. I'll make it 3. Doesn't matter. So I've got some function that starts here and ends up there, okay? So I'm looking at this area. They're telling me that that area is going to be the maximum value of the function times b minus a. It's going to be less than that, but it's going to be greater than the minimum function times b minus a. Someone tell me, what are they getting at here? What are they trying to tell me? Here's the maximum value right here. This is the maximum value of my function f. As the markers have. What are they getting? B minus a times the maximum value of the function. What is that they're getting? Yes, Abigail.
I'm saying that the area is going to be between like LRAM and then RRAM. So
Beautiful. Yeah, Abigail's making the point the way I drew this. She's going, hey, the true area is going to be between LRAM and RRAM. Because LRAM is getting me the minimum possible area, okay? And RRAM is getting me the maximum possible area. Are you guys okay with that? That the true area has to be somewhere between the pink area and the blue area, because the blue area is the minimum possible area because that's my minimum value of function, and the pink area is the largest. But, you know, I drew this so that it would look like an LRAM, RRAM situation, but it doesn't have to look that way. I could have drawn it like this, and here, I'm going to put it over here. I could have drawn my function like this. Here's 2 and here's 5, and it goes, okay, like that, where here's the maximum value of the function, and here's the minimum value of the function, right? So you notice it's not the endpoints, it's not an LRAM, RRAM situation, but still, are you okay that if this is the maximum value, then this rectangle, whose height is the maximum value, is the maximum value of the integral. My integral can't be any more than this pink rectangle, right? The true integral can't be any more than that, because no part of my graph is higher than that. And similarly, this area can't be any less than this, because that's the minimum value. You guys okay with that? We're going to get an example number 2, where we actually put that into practice. Okay, here comes the last rule. domination. Please read domination and tell me what it says. Alrighty. Hey, someone explain to us, explain to us, what is domination telling us about these integrals? Let me see if I can get someone besides Angie or Abigail. What is that telling me? And you can explain it graphically if you like. Here, I'll get started. Here we go. Okay. Explain it graphically. What's going on there? Someone better raise their hand or I'm going to call on Kimberly. Yes, Lauren.
I think it's saying that if you have graphs,
Yes.
f of x and g of x,
Mm-hmm.
if f of x is graphed higher than or like it's greater than g of x,
Uh-huh.
the area below f of x would be greater than the area below g of x.
Okay, so like here's f of x and here's g of x. Let's say I'm taking the integral from a to b. Are you guys okay that what Lauren says is correct? That the area under the graph f of x is going to be greater. The area under the graph f of x is going to be greater than the area under the graph g of x if f of x is bigger than g of x, if f of x dominates g of x. You guys okay with that?
Yes.
Alrighty, and let me ask you this. What if they're below the x-axis? What if this is f of x and this is g of x, right? Who's in domination right now?
F of x.
Yeah, f of x, he's still above g of x. He's still dominating him, okay? And so, well, but isn't g of x get more area? Look at all this area.
But
The
it's
g.
negative.
Oh, what's that again?
Negative.
Oh, that's right. It's negative area. F of x is still bigger than g of x. He's just less negative than g of x in that situation. Okay, great. Well then, hey, let's do some practice problems. Okay. I'd like everyone to please do problems A, B, and C. Good luck. Let's do A, B, and C right now.
Right this right.
Right this second. A, B, and C. Dominate. I'll give you another minute. Okay, you ready? No? Okay, I'll wait. I'll wait. Great. Now I guess say it's good. How many people, what'd you get for part A?
2.
How many people got positive 2? Yay, everyone raise their hand. Part B, what'd you guys get for part B?
3.
How many people got positive 3? Did anyone get something else?
Yeah.
Is it positive 3 good for you? Okay, you guys okay? The integral from -1 to 1 is 5. The integral from 1 to 4 is -2. So add them together and you get 3. The integral from -1 to 1 plus the integral from 1 to 4 is going to get you the integral from -1 to 4. And how about C? What did you guys get for C?
31.
How many people got 31? Yay, good for you guys. Okay, look at D. Look at D, the integral from 0 to 1 of f of x. Well, we've got the integral from -1 to 1, that's equal to 5. So tell me, wouldn't the integral from 0 to 1 be 2.5?
Yes. Right?
Why? Okay. You think the integral from 0 to 1 is 2.5? Would someone be able to disabuse me of that notion?
I mean, it could be true, but
What's that? Okay, if the function's a straight horizontal line, could you give me a scenario where the integral from -1 to 1 is 5, but the integral from 0 to 1 isn't 2.5? Yes?
I can't give you like the equation, but you can say that like from -1 to 0 is 4.
Okay.
It's gonna have an area of 4
Uh-huh.
from 0 to 1, and then from 0 to 1 it would be 1.
Okay. You guys okay with that? That if my graph looked like this, where from -1 to 0 the area is 4, and then from 0 to 1 the area is +1, that gets me my 5. But obviously -1 to 0 isn't 2.5. See, you never know unless they specifically give you the bounds. You don't know. Just because from -1 to 1 is 5, it doesn't tell you anything about what the integral from -1 to 0 is. I could have drawn this graph like this, right? I could have gone like this, you know, where from -1 to 0 is some huge negative number, and 0 to +1 is a huger positive number. How much huger? 5 huger, you know? I mean, there's no telling what's going on. All you know is from -1 to 1 is 5. Okay, look at the second one. The integral from -2 to 2 h of x. Well, the integral from -1 to 1 of h of x is 7. Doesn't that make the integral from -2 to 2 14?
No,
Why not?
because you don't know the equation.
Yeah, you don't know what's happening from -2 to -1 or from 1 to 2. You have no idea what's happening. You can't speak about what that integral is at all. You just know from -1 to 1. And look at f. Why am I not able to get that? What's that?
It's-
Oh, because you don't know -1 to 4 from h of x.
Yeah, you don't know -1 to 4 of h of x. You know what it is for f of x is 3, but you don't know what -1 to 4 of h of x is, so you're dead in the water. Okay, great. And then, hey, there's one last thing I want to do with you. And then guess what, man? We're done. We're done with like 8 minutes left to go in the period. How do I know that that integral has to be less than 1.5? The square root of 1 plus cosine x dx? How would I know that that integral from 0 to 1 has to be less than 1.5?
Because after 1.5, does cosine become a negative number?
Hey, you're on the right track. You're looking at cosine x. You're trying to figure out what values cosine of x could take on. That's the right way to do it. Go ahead, Chris.
Because the value of cosine of x can only be at maximum 1. And
Good.
then when you add 1 to 1, the maximum you get is square root of 2,
Yes?
which is less than 1.5.
Chris, you're very smart. Don't ever change. You guys okay? That the maximum that radical 1 plus cosine x can possibly be is rad 2. So if I'm going to get the area from 0 to 1, and the biggest that the y-coordinate of this guy can be is rad 2, which is 1.414, then the biggest this area can be is 1.414. It can't be 1.5. Good, thank you, Chris. Wow, that saved us a lot of time. We get to go home early now. because of Chris. Is everybody okay with that? That this is accessing that one rule about min-max. That Chris, number 6. Chris essentially found the maximum value of my function f, which is rad 2, and then he multiplied by b minus a, which is 1, and got that the maximum area is rad 2, which means it can't be 1.5. Okay, hey, any questions or issues on any of this stuff?
No, sir.
Yes, Leilani?
For the first example, how did you get part D? Like, how did you know it's not possible?
Here. D. Part D, the problem is they tell me the integral from -1 to 1 is 5, but in no way can I infer what the integral from 0 to 1 would be from that information. You know, I mean, it could look, I actually drew something, you know, I drew an area where this area is -1,000 and this area is positive 1,005. You know, and that would satisfy the requirement that the integral from -1 to 1 equals 5, but your integral from -1 to 0 is -1,000, something you would never have guessed. You know, and that's the thing, it could be anything. Anything else? Alrighty then, hey, we're done.